Good day, greetings. Thank you for tuning in. And today we're going to be still focusing on the topic which is called the atom, and then we're going to be just considering different questions. We're also going to be talking about a different concept that we didn't look at in the previous videos. So thank you for tuning in, and let's get right into this. Now, in this video, this is what I would like us to have done at the end of this video. So I would like us to have defined what an isotope is. We need to be also able to represent different isotopes with their what we call isotopic notations, and also we're going to look at a June exam which has been set in this concept that we're going to talk about in today's video. Now, the elements that we see on our periodic table, they exist in nature in different forms. These different forms of a certain element, we refer to them as an isotope. Now, uh, isotopes are virtually identical in their chemical and physical properties. However, we need to take note that isotopes of a given element have atoms with the same number of protons but different numbers of neutrons. Therefore, an isotope is fully defined as two numbers. Remember, an isotope of a certain element will have the same number of protons but different number of neutrons. Remember, in an atom, we have three subatomic particles, which are electrons, neutrons, and the protons. Now, different isotopes have the same number of protons and also the different number of neutrons. That's isotopes of a certain element. Now, we have this, what we refer to as an isotopic notation. Now, take this for example. It says that thus if X uh, stands for the chemical symbol of the element, now an isotope of X is represented as the following. We use the symbol, we say that A, and then we say that Z, and then X. X is our symbol of the element. Now take for example, we've been given the isotope of uranium. Uranium, which is 235 and has a mass number of 235 also. Now, the mass number which is written at the top here is our A, and then the atomic number is the number of protons, which is 92. Now, the mass number here, what we need to know is that the mass number is the sum of the protons and the neutrons. That's what we need to take note of always. The sum of the protons and neutrons is the mass number. Meaning that in the mass number, there's the neutrons and there's the protons. And we also have the protons here at the bottom. Now, we have an example here, and it says how many electrons, protons, and neutrons does the neutral atom or isotope of chromium or Cr52 have? Now, we need to know that this Cr52 here The 52 here is a representation of our mass number. Now, the isotope has a mass number of 52. We need to find the atomic number of chromium to use our tools. Now, also, we have the tools that define the atomic number set. Remember, the atomic number always is there on your periodic table, and the atomic number always represents the number of protons that you have. Now, as a result, the we'll find out that the atomic number of chromium is 24. That means that the number of protons that we have is 24 in this chromium 52 isotope. Now remember, 52 is the mass number, meaning that the mass number is equal to, remember, the mass number is equal to the protons plus the neutrons. Meaning that if I take this 52 and subtract the number of protons from it, I will remain with the number of neutrons. So as a result, the number of neutrons are equal to 52 minus 24, which gives us 28. Now remember, for the electrons, since the atom or isotope of Cr is 24, is neutral. That means that the electrons in there are also going to be equal to the number of protons. Remember, electrons are negatively charged and protons are positively charged. So they will cancel out to be a charge of 0, which is neutral. Now, let us quickly look at the question, which was in the June exam in 2023, I believe. And then so this was question 4. It was on isotopes. So it says that two isotopes of carbon are represented below. Now this is carbon isotope, which has a mass number of 12 and the number of protons, which is 6. It also, this one is a carbon 14 atom, which has a mass number of 14 and also a number of protons, which is 6. Now it says define the term isotope. Now remember, isotopes are different elements which have the same number of protons but different number of neutrons or different mass numbers. Now, how many neutrons are in carbon 14 atoms? That's 4.2. Now, the carbon 14 will be this one, the second isotope here, and then the number of neutrons. Remember, to get it, we take the mass number and we subtract the atomic number or the number of protons. Now, drawing the Aufbau diagram of the carbon 12 atom. Remember, to draw the Aufbau diagram, the Aufbau diagram is just those boxes that we talked about in the previous videos. So now we would utilize our periodic table, and we would use the group numbers, and also we would fill in the number of electrons that we have in our carbon 12 atom. Now we're going to look at that in the next slide. Now for the Aufbau diagram of the carbon 14 atom, I said we look at the periodic table. Now, if we look at the periodic table, the carbon atom is on, it has an atomic number of 6, or it's number 6. Now remember, we fill in the number or the atomic number, meaning that that is the number of electrons that it has, since it's a neutral carbon atom. Remember, it doesn't matter if it's the carbon 14 or the carbon 12 atom. So isotope, I mean. So it's still the same carbon atom. So we're going to use our periodic table, and we write the 1s orbital, and then we fill in 2 electrons up and down, and then we write the 2s, and then we fill 2 up and down, and then we write the 3 boxes here on the 2p, and then we're going to fill only 2 because we're only left with 2 electrons. Remember, we're going to reach a number of 6 electrons. Now we're going to 4.4. Now 4.4 also, it wants us to use the Aufbau diagram to represent the sp notation, or the electron configuration. Now we just come here and say, okay, in 1s there were 2 electrons, so it just means that it will be 1s and an exponent of 2, or the number at the top will be 2. And then we have 2s also, it will be also 2 because we have electrons which are 2 here, and we also have 2p, and then we also have 2 electrons because there were 2 also even on our Aufbau diagram.